Hello, let's end our while loop with these questions. So this is how we end our while loop topic. I added some questions here. These are very important. Solve them in the same order that I'm solving. Okay. So we are just going to build some logics and understand how to build logic. Same, if you find any problem, just we write it down generally and think about the solution, how we are going to solve it, what are the steps we are going to use. In the same way, when we are doing programming, we just take that particular problem statement and try to solve that in or in an algorithm way. Okay, so we're going to build an algorithm and going to think that how we use certain terminologies in programming and solve that particular problem. Okay, let's start with the first one. So we have to enter a number from user and print the reverse of it. To print the reverse of any number, let's think about the solution first. So if I'm taking a number, for example, 143, the number is 143. Okay, so now in this particular number, if you need uh, reverse of it, okay, so reverse will be 341. Okay, correct. If we break it down, we realize that we need the first number, okay, or the last number from this particular number. We need the last digit of this particular number, that is 3. To need 3, how we are going to solve this problem? So we have a solution for it. If we take a modulus of this particular number with 10, it will give you the last digit or the one space digit. Okay, for example, if I take modulus by 10, this will give you 3, because when you divide 143 with 10, it will give you it will be completely divided 140 and 3 will be the remainder. So as modulus give us a reminder, so it will going to give us 3. So now we have the last digit. Now we want the last second digit, that is 4. To get the 4, I'm going to use the same concept, but we don't have a direct solution for this, because this particular value is a number, not a string. If this was a string, we are going to apply some other operations, but we haven't studied string yet. So this is a number. When you divide any number with 10, it will give you the ones place digit. Okay, now how we are going to solve this? We need 4 now. So let me use the same number. If I convert the previous number into 14, for example, if the previous number 143 is converted into 14, and if we are going to use the same concept, that is taking the modulus by 10, it will give you 4. How? So let me convert this. If I divide this number with 10, it will give me 14.3. Okay, but we do not need 14.3. We do not need the decimal value. So let me take a floor of it. So this is a floor operator. We already know this. So if you take the floor of it, it will give you 14. Okay, it will remove the decimal value and it will return 14. Okay. Okay, so we now have 14. Let's apply the same concepts, these two same concepts, on the same number. Correct? So we started with 143. We get the 3. Now we want 4. To get the 4, we converted this number into 14. Now apply the same concept on 14. If I take the modulus by 10, it will give me 4. Correct? If you divide this by 10, 4 will be the remainder. Okay. Now, if I convert this 14 into 1 and apply the same concept or take the modulus by 10, it will give me 1. Okay. So let me convert this into 1. So if I take the floor value of 14 by 10, it will return 1. As when you divide 14 by 10, it will give you 1.4. But this is a floor division. That's why it will return 1. It will remove the decimal value, that is 0.4. Okay, so that's it. So now we have 1. If you take the modulus by 10, it will return 1. Okay, it will give the remainder 1. As you already know the simple mathematics, if we value that we are dividing with is greater than the number, so it will return the number as it is. This is a mathematical concept. Okay, we already know this. So now if we get floor division of this, it will give 0.1, and it will not consider decimal value, so it will take the integer only. So this will be the output. Okay, so as you can see, when you take the values or take the modulus by 10, you will get the last digit. Okay, so now if we print these values, it will print the reverse of 143, that is 3, 4 and 1. So let me write the concept for it. Let me write a algorithm for it. We already think about the algorithm. Now we are going to code this. Okay, imagine variable in place of these numbers. Okay, so now if I write, let me take that number as n. For example, the number is n, and I'm going to store that number, or I'm going to take modulus by 10. So I'm going to take modulus by 10. It will give me a number. Okay, that number will be the remainder, that is this. Let me take a variable that is r and store it. Okay, so that number will be stored here. Okay, so now what is the second logic? Second logic is we are going to use its particular value, that is n, and going to take modulus by 10. Let's store this particular solution into some value, because this operation will return something. Okay, that is, this is returning remainder, and this value will return the number. This number, we are going to use this again in our next logic. So let's use the same variable, that is n, and store that. Okay, now we are going to repeat these two equations multiple times. Okay, it depends on the number of digits the number contains. Okay, so if the digit is 3, this logic will work, which should work 3 times. Okay, so we are going to use a loop here. So let me use while loop, and the loop will work for around multiple times until the value that you entered converted into 0. Correct? So if it converted into 0, the loop should stop. Okay, so we are starting for 143, and it will convert it into 0. Okay, so if I write n is greater than 0, if this condition is true, okay, so the logic will work like this. Okay, the logic should work like this, and when the value is 0, the loop will be false. Okay, so let me take the value from user, let me convert into integer, and a number. Okay, so when user enter a number, it will be converted into integer and will be assigned into n. Correct? 143, let's suppose the number is 143. 143 is greater than 0, condition true. This will convert that number, or remove the 3 the last digit from the last digit, and assign into r. Now we are going to just simply print that number. So if I print the value of r, the 3 will be printed first. Also, we have to make sure that it should not change the line, because we are going to print that number into 3, 4, 1. Okay, that's it. This is our logic. So think about it. N is 143. This condition is true. 143 modulus 10 will return 3. 3 will be assigned into r. and this particular line will print the value of r, that is 3. Correct? Cursor will blink on the next position. 143 modulus 10 will give you 14.3. Because this is a floor division, 14 will be stored into n. Okay. Loop will rotate. 14 is greater than 0. Condition true. If the condition is true, this will return 4 this time. 4 will be assigned to r. 4 will be printed here. Okay. Because of and the line is not changed yet. Okay. Now the value of n is 14. Floor division will make it 1.4 and return 1 only. Okay, 1 will be assigned to n. This will rotate. Condition will be true. This will return 1 again, and 1 will be printed here. Okay, so let's run this one time. 143. You enter this, it will print 341. So my logic is returning 341. Okay, so now let's move forward and try another question, and we will come back to this logic after solving this particular question. Okay, there's a issue with this particular logic. What is the issue? You can think about the issue. Okay, so now let's move forward. Next question is, we're going to enter a number from user, and we are going to print the addition of individual digits. If the number is 143, the output should be 8. Okay, why it is 8? Because of this. Okay, let me write this particular part. 1 plus 4 plus 3, that should be 8. Correct? So this is our logic. We have to create same concept and print sum or addition of all the values. Okay, so now how we are going to use this? In mathematics, you cannot add multiple values at the same time. How we work, how we add multiple values? We add multiple values individually. Like, we are going to add 1 and 4 first. This will give you 5, and 5 will be added to 3, and this will give you 8. Correct? We cannot add multiple values at the same time. At the lower level, we are going to add 2 values at a time. So now you can consider this as, for example, if I am using a variable called add, for example. Okay, so if I take the variable add, and this variable is 0 initially. Okay, you can consider this as a cricket match or a football match. 2 teams can play a match at a time. Multiple teams cannot play a match at a time. Okay, so initially there are multiple teams. You can consider this as, don't write like this, write like this. Okay, so we are starting with 0. Why we are starting with 0? Let me give you an example, that is this. Now we have to add this 0 with our 1 so that it will return 1, and our final value will be 1. This add will represent this addition. Okay, so now we there will be a match between 0 and 1. Whoever the winner is going to be assigned an add, the variable add. This variable add will have the match with the next value, that is 4, and the addition will be 5. Okay, so the addition will be 5, and we will store the addition into add variable. Okay, again we will get the another value, and that value will be added. It will return. It will be added with the variable add. Okay, and it will return add, and this 8 will be assigned to add, and this is our final output. Okay, so this is how we are going to solve this. We are going to use a variable. We will start this or initialize that variable with 0, and individually add all the values into it. Okay, so now let's write the same logic. So I'm going to use the same logic. Why? Because we need individual digits to add all the values. Okay, so let me use this. If I use this particular logic, let me on this again. So I'm using the same logic. Okay, we don't want to print the value, so let me remove this one. Okay, now we are going to enter a value from user. We need individual digits. Because of this particular logic, we already get the individual digit. Now we want to add all the values. How can we do this? Because initially for in the first iteration, we will get the value 3, 143. We will get the last digit, that is 3. Okay. We are going to use a variable that is add. We are going to add the value of last digit, that is r, into this. Okay, and then we will assign this value into add, because when we add both the values and assign it to add, this loop will rotate and we use the new value of add into adding it to another value. Okay, correct? So let me initialize this variable first. I'm going to give the value 0 to it. Why? Because 0 will not change the final output. So 0 will be added to the first individual digit that we extracted from the number. So number is 143. 3 will be extracted and will be added to 0 initially. And the value will be 3. 3 will be assigned into add. So initially the value of add is 0. After that it will become 3. After that it will become 7. And after that it will become 8. Correct? So if you rotate these numbers, rotate this particular function, you will get the value. Okay, so let me use a print statement. I'm going to use addition is equals to, and I'm going to print the value of add. After completion of this whole loop, all the iterations, you will get the value, get the addition of all the individual digits into add. Correct? So if you run this, you will get the value. If I write 143, it will return 8. Correct? You can enter one more number, that is, if I write 167, it will give you 40. Okay, so you can get summation or addition of individual digits. Correct? So this is how we work on this. Let me come back to the previous solution. So we are starting this particular question, that is reversing a number. Now in the previous solution, there's an issue. What is the issue with this solution? The issue is when you print individual digits, this particular number that is in the output is not a whole number. That means we printed 3 first, then 4, then 1. This is not a whole number. That means if you multiply this number by 2, it will not give you the double of it. It will give you an error. Why? Because we are printing individual digits. Correct? This is 3. In the first iteration, it printed 3. In the second iteration, it printed 4. In the third iteration, it printed 1. So it is not a whole number. So this is the issue with this logic. So we are going to use, you can call this a static logic. Okay. So we are going to create a dynamic logic here so that it should generate a whole number. If you multiply a whole number with any number, it will be converted into that number. Okay, that is not the case in the previous logic. Okay, so we're going to use the same thing. We're going to use the same logic for the dynamic method, but this is how we are not going to print anything here. Okay, so now if we are not printing anything, how we convert that number into reverse as well as a whole number? How we are going to do this? So now in that same case, we are going to use same logic, that is add. Okay, let's start with this add first. Okay, add is 0. Correct? Now if we divide any number with any number in mathematics, multiply is the opposite of divide and divide is the opposite of multiply, correct? If you divide any number by 2 and it will give you another output, okay? If you multiply that output with the number that you multiplied, you will get the previous number. Let me give you an example. If you divide 10 by 2, it will give you 5, okay? If you multiply that 5 with 2, you will get the previous number, that is 10, correct? So this is how it works. So if we are dividing the number, let's multiply it. If we are dividing by 10, let's multiply it by 10. So it will convert that number as the previous number again, but in such a way that it should convert that number into a reverse number, okay? How we are going to do this? So let me take this add and multiply this addition of individual digits by 10 so that we will get the previous number again. But there is a condition, we have to create a reverse of it, okay? So let's add that reverse to it or the individual digit to it, okay? And that's it. This is my logic. What we are doing, we are multiplying 10 by the by our addition or the summation of the individual digits, okay, and adding it with our individual digit, okay. So if you get the value, you just store it into a variable, in the same variable. Now think about it. Add is 0 initially. This is 0. 0 multiplied by 10 will be 0 because in this particular equation multiply will run first, because you can consider this as board mass, but in the stack internally multiply will be executed first because it is in the higher priority, okay. So now initially the value of add is 0. This will be 0. Initially the value of r will be 3. If the value of n is 143, we are using the same value, that is 143. The value of add will be, initially it is 0. Because of r, it is now 3, okay. This will convert n into 14. This will rotate. 14 is greater than 0. It will return 4. 4 is here, okay. 4 is here. 3 is here. 3 multiplied by 10, it will give you 3 multiplied by 10. This will give you 30. 30 plus 4 will be 34. So the value of add will be 34. In the next value, n will become 1. This will rotate. 1 is greater than 0, condition true, okay. This will return 1 again. The value of r is 1. The value of r is 1. The value of add is 34. 34 multiplied by 10 will be 340. 340 plus 1 will be 341. Value of add will be 341, okay. This will become 0. This will rotate, condition will be false. Now we get the value as a whole number. So if I write reverse is equals to, you can print the value of add, okay. Let me check if this add is a whole number or not. So let's multiply that number. So if you multiply this add with 2, it should give us 682, correct? It should give us 682. In the previous condition, it will not give you any value because these are individual digits, not a whole number, okay. So let me run this. 143, this will return 341 and 682, okay. So by this particular check, we got that this add is a whole number. So now you can, if there is a condition in your logic that get a reverse of a number and apply some operation on it, you can easily do that because it's a whole number now. It is 684, not a 684. Sorry, 682, not 682, correct? So this is how it works. Let's move on to next problem, that is write a program to enter a number from user and check if it is palindrome or not. So what are palindromes? Palindromes are just simple numbers whose reverse are the same as the actual number. For example, 121. 121, if you get the reverse of 121, it will give you 121. Simple. So it is a palindrome number. Correct? If you get 143 and the reverse is 341, these two are not equal. So this is not palindrome. Correct? So how we are going to use this? We are going to use the reverse logic like this. We're going to use the same logic. We already know how to create reverse of any number. Now we just have to check if it is a palindrome or not. Let me remove this one as well. Okay. Because of this logic, we will create a whole number as a reverse. Okay. So if the number is 121, the reverse will be 121. Now, if I write if, we just check the value that this particular add, that is the reverse, is equals to this n. If this is equal, that should print palindrome. Okay. Else let me print not a palindrome. Okay. So this is a simple check we use outside of the loop. Once the loop is completed, this add will hold the value of reverse. Okay. So if the number is 143, the value of add will be 341. So these condition will get false and will print like this. If I run this, if I get 143, it will give not a palindrome. Correct. If I enter 121, it will still give you not a palindrome. Why? Because the issue with this logic is we are using the value of n that is already converted into 0 after this particular logic. That's why the while loop got false. Okay. So now we are going to use the same logic, but we will change a little bit because this n is converted into 0. We cannot use n here. So now what we will do? We will use a temporary variable. Let me call it call. Okay. And assign the value of n initially into it. So whenever a user enter a number that is 143, this will be assigned into a new variable that is called. You can call it anything. Okay. After this particular loop, the n will be 0 and this condition will be false. We have to compare this add, that is a reverse of the whole value, whole logic. We have to compare this number with this call. Correct. So this call holds all the value, previous value, initial value inserted by the user. So this will give you a proper output. Okay. So if it is 143, it will give you not a palindrome. And if it is 121, if you reverse it, it will give you 121. So this is a palindrome. Correct. So my logic is working fine. Let's move forward and solve our last question. That is, we have to check if the number is Armstrong or not. So now what are Armstrong numbers? Very easy. Those numbers whose individual digits, the sum of their individual digits or the sum of their cube of their individual digits are same as the whole number is an Armstrong number. Okay. So if the number is, for example, 143, okay, so we have to take cube of individual digits and sum all of them. So if I write cube of 1 plus cube of 4 cube of 4 plus cube of 3, correct? So it should give you the same output as the cube of 1 is 1 plus cube of 4 is what? Cube of 4 cube 2, sorry 3, 64. This will be 64 and the cube of 3 is 27 what will be the output of this particular equation? It will give you 92. So it is not the previous number. 92 is not a, sorry, 143 is not a Armstrong number. Okay, let me take another example, 153 for example. So cube of 1 plus cube of 5, okay, and cube of 3. So what will be the output? Cube of 1 is 1, cube of 5 is 125, cube of 3 is 27. Okay, so this will be 152 plus 1, 153, correct? So 153 is same as the inputted number. That means this particular number is an Armstrong number, correct? So let me solve this question. I'm going to use the previous concept, but this time we do not need to get the reverse of it. We need Armstrong, that is cube of its individual digits. So now this is the same concept. We're not going to compare with or print palindrome, that is Armstrong. This is the Armstrong number, okay, not an Armstrong. Okay, now what do you want? We want cube of its individual digits. So if you want to get cube of its individual digits, you can just multiply it 3 times, or you can use exponents of 3. So this particular part will give you exponent or give you the cube of individual digits. R will represent initially the single value and it will give you cube. Let me convert this to like this. This is all the same concept. So now from this particular concept, initially, for example, the value of n is 153. The value of r initially will be 3, that is the last digit. Cube of 3 will be 27. 27 will be added to add and will be assigned to add. The value of add is 0 here. Okay, so initially the value of add is 0. After this particular condition, it will become 27. Okay, same as it will rotate again and again, and it will finally give you 153 again. So if we compare this, it will give you the same output. Okay, sum of individual digits, sum of cube of individual digits, correct? So it will work properly. So if you run this, if I write 143, this is not an Armstrong number. If I write 153, it will give you Armstrong. There's one more example, that is 170. This is also an Armstrong number. You can get cube of individual digit, that is cube of 7 will be 343 and cube of 3 will be 27. So it will give you 370 again. Okay, so that's it. This is how we work or build logic. You can solve these questions again and again. These are very foundational questions. We will solve further questions in our future sessions. So that's it.